This is Julie Callista, editor for Advanced Materials and Processes magazine, here at Heat Treat 2011 on the Heat Treat Beat. We're here at the Heat Treating Society Member Lounge, and we are here with Ginny Osterman, who taught the Vacuum Gas Technology short course on Sunday, October 30th, here at Heat Treat 2011. Ginny, why don't you tell us a little bit about the course?
Hi, on Sunday I taught a course on vacuum heat treating processes, and it covered many aspects of vacuum heat treating, not only the heat treating processes themselves, but the understanding of vacuum technology that goes along with heat treating. It's very important when you're working with vacuum technology to understand the gas properties, because when you're running in vacuum, you're removing gas from a furnace, from a chamber, and then many times you're working in a partial pressure. And partial pressure can be vacuum, or you can be introducing inert gases like argon and nitrogen, or reactive gases, carburizing gases, hydrogen for reducing atmospheres. And it's important to understand the relationship between pressure, temperature, and volume of the chamber. So we went over some of the different ideal gas laws for people to have a good basic understanding of gas behavior. And then we went through the design of a gas vacuum furnace, and went through the stages of building the furnace, from what type of material you use for a chamber, what the best materials were used for your hot zone heating elements, insulation, your hearth materials. We discussed the importance of understanding eutectic reactions. When you're working in vacuum and you're going to high heat, you must understand the relationship. If you have two dissimilar materials sitting on each other, that certain materials will react to form a eutectic alloy, which melts at a lower temperature than the separate elements would melt by themselves. This is very important if you're working with titanium and you're using graphite fixturing, that you must know that at the titanium graphite eutectic melting point is 1730 Fahrenheit. We also covered various heat treating processes such as vacuum gas nitriding, ion nitriding, vacuum gas carburizing. We went into vacuum brazing and talked about joining of dissimilar metals with fluxless braze material. We also then discussed the importance of different tool steels, the different processes that you need to use for heat treating tool steels, different fixturing that you might need to use in order to make sure you don't have any distortion during the heat treating process. We talked specifically about gas cooling, high pressure gas quenching, and the advances that have been occurring in the last 10 years in high pressure gas quenching. We finished up the course by providing just a little test that I gave to the participants to see that they understood everything, answered many of their questions, and I gave them my information so that when they go back home from the conference, if they have any further questions, they can contact me.
Great, thank you so much, Ginny. Again, Ginny is a consultant for solar atmospheres, and we received really positive feedback from all the students that attended the classes. So thank you so much for your time.
Thank you, Julie.